Okay, so I'm just speaking to the void at the moment. So how did I get into it? And this is the kind of checking the privilege at the door. You know, I'm white and middle class and so on. So, you know, I have all sorts of advantages there. But I didn't only think about electronics when I was thinking of going to university or something. My dad got me hooked on some really quite simple bulbs and batteries circuits, bizarre, where I worked out, you know, if you open the switch, the light went off, except in one case it went dim, and I still never worked out what that was about. But then later, there were some of these 101 electronics kits with little, a cardboard, a big sheet of cardboard with spring clips and individual components. And that really got me hooked on electronics and electronics, building my own circuits and soldering them up with a soldering iron. Also etching my own PCBs, but never tell my mum about the hole I scorched in my brand new carpet with the etching chemicals. How she doesn't know, I didn't know, I don't know. Anyway, and then late 70s, so I'm an old geezer, as you'll see from my beard in a minute when I have video, got to play with computers. And the advantage of those is every time you wanted to make a change, you didn't have to order new components by mail order and wait a couple of weeks and spend your pocket money. So I kind of got deflected a little bit into software, but really I've always been interested in everything. Yes, I do write my own web pages too, but all the way down to making electronics that interacts with computing gear in most cases, not always, but mostly that interacts with computer gear. So being a hardware developer, I would say, if you purely do electronics, you're probably called a hardware engineer. I like to do stuff which is right at the boundary where I'm designing the circuits and squeezing every possible ounce of value out of them with some code as well. So, right, can everyone see my second slide here?
Yep.
Okay, so this is just some pretty pictures. So the little robot on the left, my job before uni, we were working with the two biggest toy manufacturers in the world, who may still be the two biggest toy manufacturers, Tomy of Japan and Milton Bradley in the US. And we built this little robot, this autonomous robot, which would scoot around and interact with you, and you could stroke it and you could talk to it and it would flash its eyes at you, and stuff. And if you go and search in YouTube for Wogan Scamp, I think you'll bring up the little video with this in. Wogan is another relic of the 80s. But I've done all sorts of things. So the current stuff I'm working on, I'll show you later on live video, as it were. The thing with the 5 on it is a smart radiator valve that I've designed, which saves up to 30% of your heating energy use. And doesn't require you to program it or anything. It's not fancy, it doesn't have an app. And below that one, the thing with the strip board on and the colored wires, is an early prototype for it that was hand soldered. And then just off to the right is a schematic, a diagram of a thing I still use, but in a slightly different way. I power my web servers and stuff. I used to run an internet service provider, an early one in the UK, and I had racks and racks of machines. And then when I had my second child, I had to give up my office and all those computers. And so I've started running all my servers off grid. And this is a little circuit when I then had a laptop that was doing the work of all my servers to switch it between mains power and off grid power. So quite a few different things. So yeah, I was slightly distracted for a bit. Scamp there was before and during uni, so that's all the way back in the 80s. That used the same chip as the Spectrum 48K and so on, if anyone of you remember that, as Z80, Z80A. I've shown you the radiator valve, which has been all this century, as it were. But I got distracted in between, even though I never stopped tinkering. So what did I get distracted with? Well, AI and computing degrees. So I actually have no formal electronics training at all. And Kim and I were discussing earlier, it is important to know that you don't have to spend thousands of money and years of time on fancy degrees or courses to get the skills. I don't have any formal electronics at all. No one has ever argued with any of my electronics designs. So, you know, there is lots of material online, and you can do stuff yourself if you've got a soldering iron or a breadboard or whatever. So what else did I do? I found the skills you learn when you're doing low-level electronics like this that talks to computing really helpful in all sorts of other areas that I worked in. So I helped design a battleship. It's still the Type 23 frigate. There's still a few of them around. Which bit was I looking after? Identification, friend or foe. Creating one of the UK's first internet service providers and Europe's first virtual credit card. And I worked in finance for a couple of clients, amongst others, who you might remember called Lehman Brothers and Royal Bank of Scotland. So, you know, just slight distraction in the middle. So what does a hardware developer or hardware engineer role have? Well, you could just design the electronics, and there are certainly people who do that. One of the wonderful experiences I had doing that Scamp robot in the 80s was working with Tomy, and they had magnificent electronics engineering department. I mean, it was great. So I would sketch up a design. I remember doing a hand clap detector, which detected you doing that. There's a little bit of discrete electronics with some op amps and stuff. Don't worry if none of this means anything to you. Faxed the diagram, the circuit diagram, over to them in Japan. Someone must have picked it up straight away. And basically, sort of 24 or 40 hours later, by FedEx came back a finished circuit board with a working circuit with corrections. I mean, amazing. Right, now these days, you can achieve the same thing without having the biggest company of its type in the world via all sorts of other routes. But, you know, you can do discrete electronics. But generally, it's also writing code to talk to it in C or C++. And these days, if you're lucky, it'll be something like Rust, but it might also be assembler, might be Java, might be all sorts of things. And it is useful to code all the way up to an application or HTML or CSS or JavaScript, because sometimes you need to make sure the interaction with a human being is right. Even if you're not the best web designer or whatever on the planet, being able to get something rough and ready working is handy. These skills all the way up the pile are really handy. So all of these skills, in fact, no one's ever formally taught me HTML either, but if you go and look at any of my websites, you'll see I've written hundreds and hundreds, thousands, depending how you count it, millions of pages full of HTML as well. So none of my formal skills are the ones that I've paid to learn at university. And you know, there is so much stuff online. As long as you can be disciplined and learn stuff, and the working on your own without supervision is another useful skill these days, given we're doing more working from home, you can be up there with anyone else. Just a little word on schematics. I don't know how well this one comes across on your screen, but don't try and read too much of the detail. If you're doing electronics, so if you're writing code, you will have screens full of lines of text, possibly colored these days, so you can see what each bit of your text does. If you're doing electronics, you end up drawing diagrams like this, usually sketched out on pieces of paper badly, and then eventually turned into diagrams on screen. Now, I'll show you later, when I come off this slide pack, I'll show you what that corresponds to. But basically, this is a simpler early prototype of the radiator valve. So the big blob in the middle is the microcontroller, which has the program inside it, and very clever bit of electronics. Then all the little boxes around it are peripherals, how I turn on the light on the top of the device, or how I sense light levels in the room, or how I am measuring temperature, or the top right-hand corner is a radio, for example, so I can send and receive radio. So you will get to write, you will get to do schematics. Again, the stuff to create this diagram was again all free. This, I can't remember what package we used. This was Eagle, which probably isn't free now, but there are plenty of alternatives. So I'm a cheapskate. I pay almost nothing for my tools, and I'm using them all legitimately. So some good and bad points about being a hardware developer. The first thing is, I think everyone will tell you, and I think it's been true for, goodness, all the time I've been working, 30 years or so, that an equivalently skilled hardware person may get paid less than an equivalent of than their software buddy. True and not true, maybe, but just watch out for that. You can be, there is an inclination to underpay people who do electronics because everyone thinks that software people are the rock stars. But bullet point number one here is, hey, it's all very well stirring up another Facebook or whatever, but ultimately it's the hardware people who make it interact with the real world, make your smartphone smart, that can turn lights on and off, open doors, turn on radiator valves, open water and let them through dams and stuff. So just remember that if you do hardware, you're the people who really interact with that real world, and everything else is just a passing fad, right? And I find the bridge between software and hardware really fascinating, squeezing out every last drop of value from the hardware. Hardware is hard. Manufacturing is slow and expensive. For example, if I want to do another manufacturing run of my radiator valves right now, I'd have to stump up a minimum of probably £100,000, whereas you can knock out another software release without any minimum cost. Right, and there we go. That was keeping it to 15, 20 minutes, but tell me. Right, and I'm going to put video on. Right. Kimberly, do you want to? I haven't been flooded with any questions. Let me show you the. This is the thing I had on the screen, by the way, the Radbot. So it's a radiator valve. Sorry. You select the comfort level and so on, just like you would with any ordinary mechanical one. Here, for your reference, is what a prototype of the electronics in. Can't do this right. The electronics inside looks like. The radio is on the back. The microcontroller is on the front. The tiny little dot here is the microcontroller. That's a little push switch on the top. And a predecessor, the one whose schematic you saw, was this one. Now, this doesn't have the thing to push the valve up and down, but it's got much of the same brains and so on it. And as I say, it was an early prototype. So those were some toys I brought with me. Any questions? Everyone is stunned into silence.
Let's give it a minute or two. Sometimes when people are typing, it can take a minute or so to drop in.
Or you can just type badly like I do when trying to do it too fast.
Oh, here we go.
Oh, manufacturing. Well, it's like one of those things, how far back do you want to go to the start of the universe or whatever? You need to get a design which is going to work. So we prototype stuff. And so, here was an early prototype, which we made the PCB. We designed ourselves. We got the PCBs made in China cheaply and shipped here. If you'd attended Bruno's thing last week, you'd see that his was his design for the 3D printed box. So that's one sort of manufacturing, right? And we soldered these boards up ourselves. So that's very low volume. But by the time you want to start getting things done at a price, we're aiming for this to be in the shops in the sort of 20, 30, 40 pound range. You need to be getting it up to 20% of that or something coming out of the manufacturing. You need to get all the costs down. You need to design the plastics. You need to make a minimum of 5,000 to 10,000 to get decent prices on your manufacturing and so on. Lots and lots of skills, a whole bunch of stuff which I've had to learn. DFX, design for the X stands for M for manufacturing or T for testing and stuff like that. So there's a lot of work goes in, and little things like you have to get these things CE stamped. So although that all goes away at the end of the year and we get UKCE, UKCA, but you have to get the safety stamp and the thing which says that it doesn't blurt on the wrong radio channels and so on. So there's a lot of stuff goes into manufacturing. And one of the reasons I suspect a lot of Kickstarter stuff gets into trouble is it's always at least about 5 times more expensive than you'd think and takes longer than you think. Does that answer any of your question, Mabel? Okay, was there, what are some of the obstacles? Okay, so electronics costs a bit of money, right? I did find home computing was cheaper because when you change your mind, you didn't need to fork out more money and wait again. Letting the magic smoke out, as it's jokingly called when you destroy a bit of electronics, sort of makes you wince a bit. You need a relatively steady hand. Actually, my hands are steady enough to do this sort of soldering, where you've got a thing with 0.1 inch grid on it. My hands are not steady enough to solder this sort of stuff, where some of the components, if you lose them, are smaller than a grain of salt. Just can't do it, right? Steady hand is really helpful. As with any coding or design thing, coding, you need a fairly logical way of thinking about stuff. Some of these things are difficult to get into. The courses are expensive, so can be. Depends what you want to do. And you need to get a bit of focus. So I think you need to play around and discover, and that might be in your career as well. Try a bunch of things out and see what you like, and expect that not all of them will suit you. Now, hopefully that won't be because of bro culture or any of that nonsense anymore. But you might just not like designing the cheap inserts to go into children's toys. You know, you might want to make EVs or power electronics that ships a gigawatt of power into the UK. You need to find your niche, right? This is my waiting for questions face. Tiny ML. Go on, you tell me a bit and then I'll answer.
Hello. I am actually just getting into TinyML, embedded systems, utilizing a lot of sensors. And I wanted to know, because you showed us the inside of the product, which I love, absolutely love. And you said you utilized a microcontroller. And that's basically the gist of TinyML. And I attended an event yesterday, and they were so excited about TinyML. And I didn't know whether this is crossing borders in terms of this discussion in regards to tiny machine learning and using TensorFlow Lite to help with these types of products that are coming out.
No, it's very much on point, right? And we've had some interesting discussions with some big companies who are interested in our tech. So just to be clear, because it took some getting it over to them, for example, this we do advertise as, you know, having AI technology, right? But depending on how you define it, the AI isn't running in here. So I've had a couple of data scientists working with me, for example, and before that, we looked through scans of data. We have gone and pulled out features in all sorts of ways to say, yeah, this happens when we're occupied, so we can use it as an occupancy signal. And some of the ways we've pulled out those. So we've got 250 million data points from a trial we just did. You're clearly not going to go and eyeball all those individually. So you then use a variety of techniques, including things like machine learning or whatever it is, to pull out interesting data points on it. And then we hand code these into extremely tight algorithms, sometimes that reduce to only 30 or 40 lines of code and a similar amount of bytes of working memory, so that they will run on a tiny microcontroller, which will run for 2 years off a couple of AA cells, and will fit. And that microcontroller only has 32K of flash. Now, so you can't really run anything that by itself is a machine learning thing on a microcontroller that small. But what you can do is take your learnings and put them on there. And this thing also does, by the way, learn about how someone uses their room. It predicts their occupancy, so on. And it's got some relatively simple but smart stats underneath it that allows to do that. But if we were to upgrade to a slightly smarter microcontroller, then we could do some more sophisticated learning when the user has it installed in their Radiator. So it's absolutely pertinent question. Where do you put the cleverness? Because a smarter microcontroller will cost more and put the cost of a product up. So it's right on. No, it's a very good question. What advice? Okay, what advice? Okay, you're welcome. What advice would you give to anyone coming into the tech industry? Oh, Well, it's a very, very, very wide area these days. It isn't that you have to have a pocket protector with 3 biros in it of different colors and an HP calculator, otherwise you don't fit in. That's certainly not true. There's just an amazing range of stuff to be done, and also not even pure tech industry. I mean, if I told you I was doing a smart radiator valve, would you have described that as tech industry? No. If I told you that thing that I did before university was making a toy robot, would you have called that the tech industry? No. And that was 30, 40 years ago, right? So I would say more like, so you can either go in and be an adaptable software person. You've seen I've done, you know, defense and finance and oil and all these other despicable things, which I'll no doubt get prosecuted later, as well as toys and radiator valves. So you can either go as a pure software person who finds a series of jobs, or a pure hardware person, or you can say, oh, what interesting problems do I want to solve, and how can I use tech to solve them? There's possibly one, I've done a bunch of startups, and one of the things which is a bit annoying sometimes is when people say, I've got this cool tech, what problems can I solve with it? And sometimes that's fine, but I think it's almost better to go and say, what is it I want to do? How can I apply my tech skills to it? Is there a job? I think people are also looked after better and paid better if they've got multiple skills, because thousands of people have on their CV Java programmer or JavaScript programmer or whatever. Relatively few people have on their CV JavaScript programmer and custodian of HVACs for the British Library or whatever. My sister-in-law is not only an amazing chemist, but she's also quite a good painter. And the Louvre had her restore some of their $10 million paintings, because she's one of the very few people in the world who can do the chemistry of the pigments and actually restore them. I mean, it's quite shocking. You can go and see where she's restored things that the public looks at. So having a range of skills that crosses boundaries, I think, is very useful. Oh, hardware design and electronics. I sort of learnt my stuff from, there was I think a range of books still exist called the Bernard Babani electronics books. I think they still exist. There was also the wonderful, came along a bit later, the Horowitz and Hill, the Art of Electronics. So I think those are still wonderful books. But what you've got things nicer now, like Adafruit and so on, where rather than having to do really, really low level stuff, I mean, all my stuff, this still thinks it's an Arduino Uno. I still program it with the IDE, the Arduino IDE. So you don't have to invent everything from scratch. You can, you know, put building blocks with have really complicated logic in the electronics, if you want, in the microcontroller, and make the electronics a bit simpler. And that's fun. And I know people are doing this in practice. They're controlling their water heaters in the middle of the Australian outback, right, where they don't have lots of fancy electronics. They have a couple of Arduinos and a Raspberry Pi controlling things. So I would say, yeah, do look at those pure electronics things, but there's just an amazing, amazing wealth of things. Try and think of something you'd like to do and see how you might apply tech to it. I think is a more fruitful way maybe of attacking some of these things. Thank you, everyone. Yeah, yeah, thank you all for the questions. Very helpful.